Test number 3, section 3, doing questions 6 to 11 on the no calc section. So question number 6. If xy is a solution to the system of equations above, what is the value of x minus y? So we have to find a coordinate which will satisfy both of these equations, making them equal. So there's two ways to do this: combination and substitution. In this case, I believe that combination is faster, so I'm going to use that. So the first thing we have to do is find the lowest common factor. So we can cancel out one of the terms, so we're only left with the other ones. So in this case, we want to cancel out 2 and 3, 2x and 3x, by subtracting them. But we can't yet. We have to make these equal to each other. So how do we do that? We multiply 2x, the top equation, by 3, and the bottom equation by 2. So let's do that. So 6x minus 9y is equal to negative 42, and then minus, because we're going to combine these two equations, which means we're going to subtract one from the other. And then 3x times 2, 6x, and then negative 2y times 2 is negative 4y is equal to negative 12. You see how we made these equal? So now if we subtract them one from the other, it's going to cancel out, so we're left with 0 here. Next, we have negative 9y minus 4y, which is negative 9y plus 4y, because two negatives make a positive, so we have negative 5y here. And on the other side, negative 42 minus 12, once again, negative 42 plus 12, which is negative 30, which means y is equal to 6. That's only 1/3 of the battle done. We still have to find x, so we can just plug 6 into either one of these equations to find x. So 2x minus 3 times 6 is equal to negative 14. And then let's move this negative 18. This is 18, negative 18. Let's move it to this side. So 2x is equal to negative 14 plus 18, which is 4. So x is equal to 2. That's 2/3 of the battle done. We have x and we have y. Now just subtract y from x. X minus y, or 2 minus 6, is equal to negative 4. Beautiful. Alright, the function f is defined by polynomial. Some values of x and f of x are shown in the table above. Which of the following must be a factor of f of x? So basically, what I thought when I did this question earlier was f of x, like a factor of f of x basically is any of the x-intercepts for that function. So let's say if this is if there's an x-intercept at x equals to negative 3 and an x-intercept at x equals to 2, let's say, we know that x plus 3 and x minus 2 are two factors of the function. So x-intercepts occur when f of x is 0. In this case, if we go down the list or go down the table and find 0, we see that x value is 4. That means that factor must be 4. Because if you plug this in, 4 minus 4 is 0, the function becomes 0, which makes sense. So it's x minus 4. Okay, the line y equals kx plus 4, where k is a constant, is graphed in the xy plane. If the line contains the point CD, where c does not equal to 0 and d does not equal to 0, what is the slope of the line in terms of c and d? Well, we know that the equation to calculate the slope is m, which is for slope, is equal to y1 minus y2 over x1 minus x2. Now we just need two coordinates to find the slope. We're given one of them explicitly, which is CD, but we have to dig around a little bit to find the other one, because the SAT will not give you everything outright. Sometimes you have to do a little bit of digging inside the problems to find the right missing number, missing word, missing meaning. This applies to all sections of the SAT. So if we dig around this question, we see that we can find another coordinate from this equation. So y equals to kx plus 4. This 4 means that there's a y-intercept at positive 4, which means we know for a fact that 0, 4 is one of the coordinates of this line. So let's just plug these values into the equation above here. So y1 minus y2, so d minus 4 over x1 minus x2, c minus 0, which is equal to d minus 4, we can get rid of the 0, over c, which matches with a over here. Nice. Okay, in the system of equations above, k is a constant and x and y are variables. For what value of k will the system of equations have no solution? Well, this question is, in my opinion, it's a little bit more difficult than the other ones. I feel like it's a little bit misplaced, but that's fine. We can still solve it. Okay, so what does it mean for a value of k? What does it mean for a system of equations to have no solution? Well, think of it this way. Graphically speaking, if two equations don't have a solution, that means that they never intersect. And what is it called when two lines never intersect? They're parallel, right? And what does it mean when two lines are parallel? They have the same slope. So we have to make sure that this function's slope is the exact same as the one below. So we have to manipulate k, or we have to find a value for k, such that the slope of this equation is the same as the slope of the one below. So let's just manipulate both of these equations to turn them into slope-intercept, so we can see the slope like easily. So let's do the top one first. So kx minus 3y is equal to 4. Okay, let's move. We have to isolate y. So kx is equal to, and we have to move the 4 here. So kx minus 4 is equal to 3y. We have to isolate y completely, so we have to divide both by 3. Divide both sides by 3. So k over 3x minus 4 over 3 is equal to y. So that's one equation done. Now let's do the other one. 4x minus 5y is equal to 7. Now move the 5 over there and move the 7 to the left. 4x minus 7 is equal to 5y. That means 4 over 5x minus 7 over 5 is equal to y. So that's the second equation. Now we can see the slopes very easily. So we have slope k over 3 and slope 4 over 5. So if we want this system of equations to have no solution, these two have to be equal, so they'll never intersect. So we can just equal to them to each other. So k over 3 is equal to 4 over 5. Let's just cross multiply. So not cross multiply, just move the 3 over there. So k is on by itself. So 3 times 4 is 12 over 5. There we have the value of k. Okay, in the xy plane, the parabola with equation y equals x minus 11 squared intersects the line with equation y equals 25 at 2 points, A and B. What is the length of AB? So, graphically speaking, what it's asking for is one value of y has 2 corresponding x values. We have to find both x values and calculate the distance between the two. Because a parabola always, well, not always, but I forget about that. Okay, so we know y equals to x minus 11 all squared, and we know we're looking for the x values for when y is equal to 25. So we do 25 is equal to x minus 11 squared. Well, you might ask, wait, how do you get two x values from one equation? Well, here's the thing. If you square root something, there's always the possibilities of the answer being positive or negative, because in this case, if we square root both sides to get rid of this exponent here, we get plus or minus 5 is equal to x minus 11. Why? Because it could be negative 5 times negative 5, which is equal to 25, and it could be positive 5 times positive 5, which is equal to 25. So the plus or minus means that it could be either positive or negative. So we have to treat the positive and negatives as two separate cases. So when it's positive, so when 5 is positive, that means the equation is going to look like this. 5 is equal to x minus 11. Move the 11 over, that means x is equal to 16. We have one value of x. So, and then the second case, when 5 is negative, then it's going to look like negative 5 is equal to x minus 11. Now we're just going to move the 11 over again. So negative 5 plus 11 is 6. So 6 is equal to x. We have the other value. Now we just have to calculate the distance. 16 minus 6 is equal to 10. Perfect. Last question. In the figure above, lines K, L, and M intersect at a point. If x plus y is equal to u plus w, which of the following must be true? Okay, so we know that this angle... What is this? What's going on? Oh, sorry about that, guys. Okay, so we know x plus and y and w and u are the same. What we can conclude from that is that x and w are the same, y and u are the same, and that z is equal to t. Because if x plus y is equal to w plus u, that means x plus y plus z is equal to w plus u plus t. So we know these are the same, these are the same, and these are the same. So is x equal to z? Yes, that's true. One way I like to look at this to figure this one out, well, first of all, it's a little bit intuitive because one way I look at it is like this. Because since the figure is not drawn to scale and the similar looking angles could be a little bit deceiving, what I do sometimes is I turn it into a very extreme case, which, let me do it like this, where the side angles are very small and like the side as I refer to these ones, and this one's big. Now I can easily tell that this one's equal to this one's equal to this one, and this one's equal to this one. So based on that, I can tell that x and z are the same. Is y equal to w? No, we don't really know that. And since we don't know that, we can't assume yes, so this is out of the question. And 3, is z equal to t? Yes, we figured that out earlier. So 1 and 3 are true, which means 11 is B. That's questions. Let's see. Whatever, I'll figure out later. That's question 6 to 11.